use our equation to predict values, they won't be exactly right. Because our line that we wrote is the best approximation for the data. Right? Not or something. That data does not lie in a straight line. So when I wrote the equation in line, it doesn't fit all the points exactly. The difference between the actual value and the predicted value is called the residual. So the difference between the actual value and the predicted value is called the residual. So if the residual is a positive number, if I do this subtraction and I get a positive number, what does that tell me about my model? This is your model, your prediction. If this right here gives me a positive answer, then that means my model underestimated. If I do this subtraction and I get a negative number, then that means my model overestimated. With a good model, you have some of both. Does that make sense to you? Some of your numbers are a little too high and some of your numbers are a little too low. If every predicted value was too low, then there's something wrong with your model because you want it to kind of go through the middle of all the points, right? Okay, so, okay, wait, let me find my notes over there. All right, so we have already put, those are that table there, we've already put all that into our calculator, all right? Now we're going to find the residual of a baby that's 5 weeks old. And we're going to do this with our calculator, okay? And then we're going to do it by hand also, but we're going to do it with our calculator, all right? So here's what I want you to do. I want you to go to stat plot. So can you find that? It's right above the y equals. Got it? And it should be highlighted plot 1. So just press enter and turn it on. So it says on, off. It was probably off, and now we're going to turn it on. All right? Now we're going to go down the list, and X list should say L1, and Y list should say L2, but we don't want it to say L2 anymore. We want it to give us the residual. So go down to where it says highlight L2, all right? And then go to second list, and the very last option there is residual. So press enter, and now does it say Y list is residual? All right, so let's go through that one more time. So go to stat plot. You have it turned on now. Go down to Y list. Go down to Y list. And then we do not want L2 there anymore. Okay, so we're going to change that. So you're down the L or the Y list line, right? Then press second stat. And the last option is residual. Press enter, and it will put residual then in for Y list. Okay? Now, press zoom 9. I think it's 9. Yeah. Zoom 9. And your calculator should give you a residual plot that looks like On the other side of the paper, it should look like what's on the last screen. On the other side of the paper down at the bottom, is that what yours looks like? It should look like on the other side of that page, down at the bottom corner, that last screen. Okay? Now, hang on a second. These points represent the difference between the actual value and the predicted value. So do you notice how some of them are negative and some of them are positive? That is exactly what we want. All right? Now, if you press trace, it will tell you the residual. So the residual for 4, you just press trace, the residual for 4 is negative 0.085. Then you arrow, the residual for 5 is negative 0.07. Keep arrowing and it's going to give you all of the residual values. So this particular problem said, find the residual of a baby that is 5 weeks. So the residual for a baby who's 5 weeks old is negative 0.07. Now, let's interpret that. What is the interpretation of that? We're going to go through and do it by hand. But your calculator is going to be useful, so we want to make sure we can do it on our calculator. What's the interpretation? If the residual is negative 0.07, for a baby that's 5 weeks old, the model overestimated by 0.07 pounds or kilograms, whatever our measurement was. Okay? Now, see if you, using your model that you built, that's your equation, this is your model, your equation, and the tables and the value, or table of values, see if you can do the calculation by hand and get negative 0.07. All right? So see if you can, this is the calculation by hand. Take the actual value, that's the value that's in the table, find the value using your equation, and subtract those, and see if you get negative 0.07. Let's draw it. You really did it in there. Okay, so for a 5-pound baby, what did our model say? What was our equation? So for a 5-pound baby, our model said 4.47. For a 5-pound baby, the actual data was 4.4. So the actual, out of the chart, somebody measured this baby and it was 4.4. I used my equation put in 5 pounds, put in an extra 5 pounds, and got this. What happens when I subtract those, you guys? Negative 0.07? And isn't that exactly what my table said it would be? Yep, sure enough. Alright, example 3. Using the model found in example 1, a baby that was 7.5 weeks old had a residual of negative 0.7. What was the actual weight of the baby? So remember, the residual, negative 0.7, is the difference between the actual weight of the baby and the predicted weight of the baby. What was the predicted weight of that baby? I need to type that in on my calculator. I like to do it with the y coordinate and just put in 7.5. 4.9325 was the predicted weight using the equation that we built yesterday. Right? Remember our equation? For a 7.5-week-old baby, so 7.5 in there, this is what you come out with. Okay, so we'll just take that number and add it. Did you get the actual weight to be 4.2325? Wait, that doesn't make sense. I didn't, that doesn't make any sense to me.
That's what I calculated, but it doesn't make sense with the other days.
Did somebody else get that so I don't have an arithmetic mistake?
We got that.
I got that. You got it.
Well, that doesn't make any sense, but that's what the math says.
Yeah, this.
It said it was negative, right? Okay, well, we didn't make any mistakes. If somebody else matched my arithmetic, we didn't make any mistakes. That is a very small number. But that's what it is. So there we go. There we go. All right, and then sketch the residual plot for the 5 data points in the table. Well, it should look exactly like what's on your calculator, which looks exactly like this, the other side of this paper. They did it for you right there. They just showed everyone there, the picture. So keep in mind that your residual plot, here's 0. These are going to be positive, and these are going to be negative for the data points. So for 4, 5, 6, 8, and 12. So 4, the residual of 4 was residual at 4 was negative 0.05. And at 5, it was negative 0.07, just a little higher, and so on. Just plot those points. And again, if you have it graphed on your calculator, you can just trace and arrow through, and it will give you all of the residuals. Let's try another one. Let's go on to example 5. All right, we're gonna put some new data into our calculator, so let's put in the new data. Here we go. How do we put it in? We go to, where do we go? Stat, edit, and your X's are your L1s, and your Y's are your L2s. All right, so we're going to start all over. Brand new problem. Everybody's typing in data. And as you're typing, think about that first question. We have to write a regression. Last time we did a linear regression because he told us to. This time he's kind of leaving it up to us. It says linear, quadratic, cubic, or rational. Think about linear and cubic. Linear and cubic, aren't the values generally always either increasing or decreasing for a linear or a cubic relationship? That does not seem to be what we have here. Would you agree with that? So it's not those. What do you think about quadratic? What will happen in a quadratic set of data? It's gonna go up for a while and then come down, and it's somewhat balanced. Remember, this is data, so it's not perfect, but it's somewhat balanced. Does that seem to be kind of what's happening here? Yeah? Let me show you a way you can verify that on your calculator, because you guys need to practice anyway. So we're gonna go back to stat plot. So our new data is in now. Okay, we're going back to stat plot. I want you to, in plot 1, where we were before, where you put in residual, I want you to take that out and put back in L2. So we'll go to second stat, go down to L2 and press enter. And now your X list is L1 and your Y list is L2 again, right? So hit zoom 9, and it plotted the points. And just as you predicted, what shape did it plot? A parabola. So you plotted your points, and you got a handy dandy parabola. Now, did it also put in a line? Does yours, you have a little line down there at the bottom? That's the line we had stored in there from before. So we're going to change that in a minute. that's the line that we had in there before.
I have like just the problem.
That's okay. Your line isn't showing up, that's fine.
Well, like it, wait, so we're supposed to have one?
Oh, did you already do the regression? Yeah. Yeah, that's fine.
Yo.
Okay. So, all that was, kids, that was not a necessary step, but let's say you couldn't figure out what kind of thing you had, you can always plot the points on the calculator, which is what we just did. You knew it was gonna be quadratic, you were right, it's quadratic. Okay, so now we're going to do the regression. So we go to Stat, Calc, and go down to quadratic regression. And we're gonna store this equation. So remember those steps, we're gonna store that equation. And it gives you the equation, a negative 4.883x squared plus 15.958x. Please tell me this is what you have, plus 4.996. The only way we won't match is if I type my numbers in wrong. So does that match anybody's quadratic regression? Now, when I press graph, Charlie, the curve does go through those points. And it's a pretty good match, actually, isn't it? Okay, so let's see what we're supposed to be doing. Okay, write the equation of the regression model. You did that. You wrote the equation for the regression model. That's it, right there. So where did that come from? Stat, calc, quadratic regression. And then it just magically did all the work. Okay? He doesn't ask us for a residual plot here. Let's just do it, just for fun. So what do we have to do? If we want a residual plot, we have to make one change. What do we have to do? Go back to stat plot and change Y list to residual. And then zoom 9. So did you get a residual plot?
Yeah, please switch it to.
Plot. Residual. Yeah, I like zoom 9. But then your plot. Okay, now, what do you notice about these residuals? What do you notice about them? Let's see.
Anything.
German and grandfather look on my. I like great.
You've never done anything like this, and it just
He has this.
I did not do that on that.
Sounds good. I'm gonna go to full. Maybe that's what she's doing. Yeah. So did you not like the
You guys catch
What did we say was a good residual plot? What should we see? A balance, right? Some points above, some points positive, and some points negative. Now, this one has 3 points on top and what, 5 points on the bottom? So 3 positive residuals, 5 negative residuals. But would you consider those balanced? Yeah, because that one is so far up there that it takes more down here to balance that out. So that's a pretty good residual plot. All right, remember, if you're interested in any of those particular points, you simply hit trace and you can just click right through and get the residual values for any of the points in question. All right, we're gonna do one more and then we're gonna do some review work with our transformations. So example 6, we have a new table of values. So how do we start? What are we gonna do? Stat edit. You got it. All right, so here we go. Use a logarithmic regression. All right, so you can do that once you have all your points in. Then you're going to go to stat again, calc, and go down until you find ln reg, logarithmic regression, ln. How does that look? Anybody get that? For your equation?
Yes.
The residual plot is provided below. What are the coordinates of the labeled point R? All right, so you're going to do the residual plot on your calculator. So you're going to, what do we do to get that plot? We go to second, stat plot, make sure you have L1 and residual, and then zoom 9. Did you get a plot that looks like this? Yep, and we want to know a particular point, so we'll just press trace and click until we get to that point. It says, what are the coordinates? What do you think the coordinates of that point are? 1.6, negative 0.418. The point he asked about. Does that residual, negative 0.418, indicate that the model underestimates or overestimates at this X value. The residual, oh, I erased it, but the residual is negative. And residual is actual minus predicted. So if that is a negative number, that means your predicted was too high. So the model overestimated. Right? Because the residual was negative. Okay, now, by the way, when the plot is turned on, which it is right now, I just turned my calculator off, my plot is still on, that's fine. Sometimes that causes regular graphing to glitch. So if you, let's say you're graphing something in another class or something, and it's not working, try turning that plot off, and that may fix it for you, okay? We need the plot on when we are physically plotting points, otherwise there's no need to have it on, okay? All right, so now here's what's gonna happen. I'm gonna hand out a little bit of review here for transformations. We're switching gears, but if there's somebody who doesn't have your calculator figured out, while the rest of us are working on this, I want you to bring it up to me. All right, so this has a ton of problems on it. I'm gonna kind of direct you what I want you to do. All right, so here's the first ones we're gonna work on. Right there on the top page, we're gonna do 1C and number 2, all. And then on the very back, so just clear to the very back of the whole packet, did I not give you one? We're going to do number 12, which is a graph. Okay? So we're starting on the front side, 1C, number 2, all, and then on the very back, number 12, which is a graph. Now, is there anyone, we're not gonna spend more time doing this now, we're gonna just know how to do it from now on. So if you don't know how to do this on the calculator, come up. If you're having trouble with your stats and your residuals and all that. Anybody have a question about that? Get up here.
So last year, my calculator, so it doesn't have like one do, and she said she just waited.
Yeah, that's fine. What that means is when we go to stat plot, you're not gonna be doing L1 and L2. Did it work with L1 and L2?
No, that's what I
Okay,
was like.
so you need to change it. So it needs to be L3. So we go to this, L3, and what was the other one, L4?
Yeah. So I don't know, like, what those good one.
Okay, so now it should work. Because the plot's turned off. We need to turn it on. All right, now it should work. Yeah, there it is. It should work. And I think it's gonna stay, you know, I think it'll just stay that way for you. All right, anybody else?
Yeah. Sorry.
All right, we're gonna give you 5 problems. Anybody who gets any of the 5, bring it on up, put it on the board for us to look at. And we'll do a few more.
that needs to be 3. So 20. It's just 1.
You're right though.
So you got now. Okay.
No, I see when you put 6. You have to find. We know you're right. I just did that.
That one needs
Yeah, I did all this, so I've done it.
Are you mad pizza?
All right, we got 1C and 2A done. All right, anybody have, how about 2B and C and then that graph on the last page? Anybody got that?
Chart.
Okay, so far I match everybody. Good job.
Oh, I see. So then if we, okay. Wait, so I don't have that number
Here
on
comes Celeste. Good job. Are you going to see?
Yes.
All right. And then, can anybody do the graph on the back? Number 12 on the last page. Kids, that would be easy. What is the transformation? What is the only thing that's happening to the picture? If the width is being halved, yeah. So you're gonna have exactly the same picture, just scrunched up. our way through that and see, cause I could have a mistake. Alright, so here we go, let's look at Celeste and C. She said our job in 2C is to find H inverse of 4, to figure out what that equals. That means H of that equals 4. So then, so what do we know about H? Okay, so is that what this is? Yeah, because H is 5 minus f of 2x. So she says H of A would be 5 minus f of 2a, but I know H of A is 4. Okay, so you subtracted 5 and got negative 1 equals negative f of 2a. So you got rid of these, perfect. Now, Celeste, f of what is 1? Look at your chart. F of what is 1? F of what is 1? What x gives you a y of 1? Negative 3. So whatever is in this parentheses right here has to be negative 3, because f of negative 3 is 1. Would you agree? So negative 3 has to be your 2a, so a is negative 3 halves. What did you say, Charlie?
Oh, nothing.
Okay. All right. Along those same lines, let's look at problem 9a. We're gonna do 9a. So I'm gonna turn over that first page. 9a. I have another chart full of values, and it says h of x is 6f of x plus 2 minus 3. Alright? And it says find f of 4. Now remember, your chart of known values is your h function, not your f function. So we're kind of working backwards here. My job is to find f of 4. That's what I want to do. If I want to find f of 4, then I'm going to have to let x be 2. So h of 2 will be 6 f of 4 minus 3. Would you agree with that? Well, what's h of 2? That I know. That's in my chart. H of 2 is negative 3. And I am just going to solve for f of 4. So if I add 3, I get 0. If I divide by 6, it looks like f of 4 is 0. Now remember, that table of values is not an F. Don't be looking at that chart. You are using that chart of H's to figure out the F's.
Where did the H come from?
I need to find F of 4.
Yeah.
So I need X to be 2. That's how I get 4. It looks like 10 is the same thing, so let's look at 10A. This time we have a G function. So H is negative 2G of X over 2. And I want to find G of 6. Keep those beady little eyes away from that chart. You're not looking at that chart. That chart is H's. If we want to find G of 6, then we're gonna have to let x be what? 12. Because if x is 12, it says h of 12 equals -2 g of 6, and that's what I want to know. So what's h of 12? Now look at the chart. H of 12 is 11, and that's -2 g of 6. This is your variable. So what's g of 6 equal? -11/2. Alright, now you try one. Try 9b. 9b. Anybody have an answer? What? 2/3. 2/3. All right. Skip down to the very bottom of that page, number 12A. 12A.
Oh, you guys. Or, you said it up there. Page 22. If you make, it's just 1, and then it becomes 4, and then 6. Which one is easier?
Anybody got it? What? 104, that's what I got too, 104. Because, well, h of 6 is 8, that's a no-brainer. H of 6 is 8, and then w of -2 worked out to be 13 for me. We're about out of time. How do you do problem B? What does that notation mean? Find h of -5, which would be 6. And then find w of 6, right? And then same thing with c. All right, we'll pause there. We'll do some more review next time, finish up our notes. So not assigning 113 yet, we still have a few